Now we're ready to do 20F, which is on variance and standard deviation. So up till now we have learned about a measure of the spread, which was the IQR and the range. But one of the limitations of the IQR and the range are that they only, like the range only uses the min and the max. It doesn't use all the data in between. And the IQR only considers the middle, kind of the middle half. So the outer half, 2 quarters, don't really play into it. But the variance and the standard deviation take into consideration every single data point in the set. And let's just go ahead. And so variance is a measure of these are actually both measures of the spread. Both of these measure the dispersion of this or the spread of the data. And they consider every single data point in the set. The variance of a sample of n data. I should have looked on the formula sheet to see if this is something. We get lots of interruptions. I should have looked on the you'll have to look on the formula sheet to see if this is something that's given to you or if you have to memorize it. And it's denoted S sub n. Now the reason is the variance is actually the square of the standard deviation. That's why the S stands for the standard deviation. And it's going to be the summation from 1 to n of x sub I minus the mean x bar squared all over n. It tells how far on average the data is from the mean. If you were just to take each data point, so the x sub i's are each data point, if you were to just take each one of those and subtract it from the mean so that you'd get how far away it is from the mean, and you did that to every single one, and then if you were to sum those up and then divide by n, you would actually get 0. Because half the data points would lie above the mean and half would lie below. So when you average them, they would just cancel each other out and you would get 0. So that's why the formula is not this simple. So what we do instead is we square this, and then that makes everything positive. So then you're summing the positive differences, the squares of the positive differences. That's called variance. Oh no. Oh, that's because I just converted a video, so never mind that. That was video E. Okay, back to what I was doing now. Now see, it got me off my train of thought. Oh, so this is the variance. And then, yeah, I was just looking at this. It doesn't matter. You can divide the n, you can pull the 1 over n out front. So it's okay to write it either way. These are both the same. But the problem with the variance, or the reason the variance isn't that great, is because the units would be whatever these units are. The units would be units squared. And they wouldn't match the units of the data. So then what we do to counteract that is we go ahead and take the square root of the whole thing. Whoops, sorry. And that's your standard deviation. So that's going to be, and its symbol is S sub n. The summation from 1 to n, x sub I minus x bar squared. I should probably write it the same way the book does. I'll just look here. Yeah, so they have this whole thing. And then the whole thing is square rooted. That's the standard deviation right there. And that's going to be in the same units as the data. The standard deviation, is it resistant or non-resistant? Is the mean going to affect it? Well, the mean is going to affect it. In fact, the mean is part of it. So the standard deviation, S sub n, is non-resistant because it is affected by the mean. It's not resistant to the mean. Resistant. The mean affects it. It's affected by the mean. Also, and this is according to our book, The IQR is useful for skewed distributions, and the standard deviation is useful for symmetric distributions. The good news is the IB requires you to use calculators to find these. However, it is handy to know the formula, because sometimes, like if you had a lot of data and you were doing, well, like an internal assessment, for instance, it actually might be faster to do this on a spreadsheet with the formula itself. So it's important to know how to use the formula and to know how to do it on the calculator. Let's use this as our example. The number of points scored by Andrew and Brad in the last 8 basketball matches are shown below. We are going to find the mean and the standard deviation for each person on the calculator. And then at the end here, we'll find the standard deviation using the formula. Fortunately, we have a fairly small set of numbers. Clear all this off. Stat, edit. So we're going to go to edit. I'll go up and clear my lists. And then I'm going to put in Andrew in L1. Follow along with me on your calculator, because you learn by doing. I'll go ahead and put Brad's in the next list so that it's there when I need it. Then we're going to go to a blank screen, second quit. And this is all one, so we're finding each person individually. So these are one variable statistics. So we're going to go to stat, calc, and it's one variable statistics, the first choice. And it does default to L1, but just to be sure, you can do second one, and that means it's doing the stats for list 1. Hit enter, and we get all this good information. X bar is 25, so we're now going to have the mean. So I'm going to make a little table. Andrew, Brad, X bar. Now, the standard deviation, that was 25, is very interesting on the calculator. You would think that it would be S sub x is the standard deviation, because I do believe we've talked about already that S is the sample standard deviation and rho is the population. Maybe we haven't talked about that yet, have we? This one down here is supposed to be the population standard deviation, but you know what? It's actually the sample. It's actually the one we want. And I do not know why the calculator does this. And I actually remember this from years ago when I used to do this. It's always been this way. It's been this way for like at least as long as I've ever worked with TI-80, any of the TI calculators. For some reason, this is the standard deviation you want. So 4.97. I'm going to abbreviate it S sub x, because that's what, or maybe it's N, whatever it is. I was going to look and see how the book did it, if they didn't even really label it. All right. Oh, they did, S sub N. Okay, it's S sub N. Now let's do Brad's. Okay, sorry. And what we'll do too is at the end of this, I'm going to go ahead, man, we get a lot of interruptions. We're also going to find the standard deviation of Andrew's data by hand, so that you'll see that we will indeed get the 4.97, in case you're not convinced, in case you don't believe me. Okay. Stat, calc, one variable statistics. This time I want Brad's. His is in L2, second 2, enter. 30.5 and 12.6 is going to be his standard deviation. 30.5 and 12.6. I have the hardest time storing numbers in my head. We have answered letter A. Which player is more consistent? So you look at the standard deviation. Andrew has a smaller standard deviation. That means his scores are varying less from the mean, which means he's more consistent. So the answer to letter B is Andrew, because he has a smaller standard deviation. S sub n is smaller. Now we're going to find the standard deviation using the formula. To do that, we're doing Andrew. The best way to do this is to make his scores in a whoops, that's 17, in a vertical format. And I'll try to write small enough so they can fit them all in one column. I hope, did I just write Brad's down? 23, 17, 31, 25, 25, 19, 28. I almost wrote 43. It's supposed to be 32. So those are the X's for Andrew. It's very noisy today. And let's write down the formula for standard deviation. So it's the big old square root of the summation of x sub I minus, that's an I, x bar squared all over n. That means I need a column for x sub I minus x bar. These are my x sub i's. X bar is 25. So I'm going to do 23 minus 25, 17 minus 25. I have to think slowly so I don't make a mistake. 31 minus 25. That's 0, that's 0. 19 minus 25 is negative 6. 28 minus 25 is 3. 32 minus 25 is 7. So those are my x sub I minus x's. Then in the next column, we're going to square those. So that's 4, 64, 36, 0, 0, 36, 9, and 49. Fortunately, we're working with numbers that are easy enough to do in our head. Now we have to sum those. So I'm going to go to my calculator. I'm going to add all these up. And to be honest, I already did that ahead of time. So the sum, I'm done with my table too, so I can just write over here. The summation of the x sub I minus x bar squareds is, let's see, where did I write that down? 198 is what I got. And you can double check me and make sure you got the same thing. Then we have to divide that by n. N is the number of scores. So I believe there were 8. Yep, there were 8 of those. 198 divided by 8, whatever that is. And then we have to take the square root of that. Try this on your own because I want you to be convinced that we did it correctly on the calculator. I got the square root of, I think is that a 24 or 27, I can't read my own writing. I don't know what that is. Anyway, at the end I got 4.97. So the square root of this is going to be 4.97, which confirms that we have to use rho of x on our calculator for standard deviation, not s. You're going to have to make sure and remember that. It's super important. Well, congratulations. We just got done with a standard deviation example, both on the calculator and by hand. So now we're going to talk about the differences in the notations. We already know the sample mean is x bar. We know this variance is s sub n squared. The standard deviation is s sub n. So those are that's the correct notation for those. The population mean is mu. And the population standard deviation is actually rho. I don't know how it's actually written out, but I call it, it sounds like rho. And then this would be rho squared. But make a note to yourself, on the calculator, we need to use rho of n, or x, whatever our calculator uses. I think it is x on the calculator. Now we can do example 13. I think that's all I was going to talk about there. Great, here's example 13. A random sample of 40... Oh, excuse me. Sorry, I had to cough. Sorry. A random sample of 48 sheep was, typo, taken from a flock of over 2,000 sheep. The sample mean of their weights was 48.6 kilograms with a variance of 17.5 kilograms squared. Notice the variance has squared units. Find the standard deviation of the sample. Well, we know that the standard deviation is the square root of the variance. I'm going to label it correctly here. It's the square root of that. And then when you take the square root of kilograms squared, you'll get kilograms, so it'll be in the correct units that you want. And when we take the square root of that, we get, I'll just do it on my calculator here. Second square root, 17.5, I'm getting 4.18 kilograms. If you have units, put them in. Hence, estimate the standard deviation of the population. Well, that is, since we often, or we usually don't actually know the standard deviation and the mean of the population because it's too big to figure out, or too timely or too expensive, we use this to estimate it. So the estimate of the population means, so the standard deviation of the population will be about 4.18 kilograms. Find an unbiased estimate of the mean weight of the sheep in the flock. That's going to be, so here they're talking about the whole flock, which is the population. The unbiased estimate is X bar, based on the sample. And I do believe we know that. It is 48.6 kilograms. So we don't have to do any math. We're just using the sample mean is going to estimate the actual population mean. So you could say mu is about 48.6 kilograms. Sorry, I'm yawning. That's the thing about the end of the day. This is standard deviation for grouped data. This is actually f.3. We just blazed right through f.1 and f.2. And I thought it was, yeah, I just copied this right out of the book. Suppose there are n scores in a set of grouped data with a mean of x bar. So we're talking about categories here. I mean, like 10 to 20, 20 to 30, and that sort of thing. If the different data values are x sub 1 and so on with corresponding frequencies, so we have the frequencies of each of these data values, then this is the formula for the standard deviation. Notice you have to multiply the frequencies times the x, times this part right here. So there's this extra little piece in here that we have to take into account. If you have an interval, a class interval, you'll use the midpoint. So use the midpoints if you have class intervals. Other than that, we can just jump right into example 14, which is going to be our last example. And we want to, so we have this data, we have these various scores and how many times they occurred. And we want to use, excuse me, sorry, yawning again, find the standard deviation. And we're going to do it using the formula and using technology. So I already set this up in such a way that I can use the formula. Sorry. Let's go ahead and write that formula back down again. Let's see, it was I equals 1. Had a pause there. To n, and it was frequency times x sub I minus x bar all over n. Take the square root of all that. Okay. So once again, this is my x sub i's. These are my frequencies. Now I need an x sub I minus x bar column, which means I need to find x bar. So you know what? Actually, I need another column before this one in order to find my mean. So let's back up a little bit. Remember, to find the mean in a situation like this, we have to find x times f. 1 times 1, 2 times 2, and so on, multiplying these together. Then we have to add them up. So let's see, 13, and that's 25, and that's 30. And you have to get the mean, you have to do the summation of xf divided by the summation of frequencies. 1, 2, 3, 7, 8, 9, 10. Oh, nice. 30 over 10, 3. We have a nice easy mean to work with. That means, another pun. We have x sub I minus x bar in this column. So x sub I is over here. 1 minus 3, 2 minus 3, 3 minus 3, 4 minus 3, and 5 minus 3. Then we're going to square those. Okay, that's 4, 1, 0, 1, 4. Then we're going to multiply those by f. Okay, so I'm multiplying this column to this one here. It's going to be 4, 2, 0, 2, 4. Then we're going to sum all those. 8, 9, 10, 12. Then we're going to take that sum and divide it by n. N is also right here. Or wait a sec. Yeah, n is the total number of data values, so that's a sum of the frequencies, so this is also n. But then don't forget, you also have to take the square root of all that. So it's the square root of 1.2. And if you go to your calculator, square root of 1.2 is 1.095, so that's going to round up to 1.10. That's how you do it with the formula. Technology. Okay, let's try that. Now this one's rather interesting in a tedious sort of way. Let's clear these out. Clear. Okay, I didn't do such a hot job. Clear. Oh dear, what's going on with you? Oh, I have to arrow down. Silly me. How do you enter this data? I can only think of one way to do it, and it's a rather tedious way. It's not bad on this problem because there's not that much data. But we're finding single variable statistics, right? So we have to have all of our data in L1. And we need every single data piece in there. So I cannot see any other way around this other than having to enter, oh gosh, fourth interruption. We have one score of 1, so I'm going to put in 1, 1. I have 2 2s, so I have to enter 2 2s. I have 4 3s. 1, 2, 3, 4. See how this is? You have to enter them all, each one. I have 2 4s, so I have to enter 2 4s. And then I have 1 5. Notice I have my 10 data pieces. I honestly think that's the only way you're going to be able to do that on this calculator. If you have a lot of data, oh my gosh, like if you look on some of these examples in the book, where they have like 13 of one item and 20 of another, you have to type that number in 20 times or 13 times. I tried one of those examples that had a lot of frequencies like that. I tried it using this table, because you can do these tables on, like you can make L1 be the X, you could put the frequency in L2, you can do XF in L3, this next one in L4, and so on. And you can do it that way, and it will work. But by the time you do all that work, it might be just as fast to just type all these all these X's in the long way. It's pretty much choose your poison. Choose which way you want to do it. So I've entered in, this is a short amount of data, so it's easy. I mean, it's not that bad. Now you can just do the same old thing. Stat, calc, one variable statistics, it's in L1. And we get x bar 3, we knew that. We get, here's my standard deviation, row of x, the same exact number we got doing it by hand. So this confirms what we just did. And you're on your own.